All right, in today's episode of Python Papi, we're back inside our TensorFlow course, and we're still doing our training and optimization module. Let's have a look at what we went over today. Now, today we went over different tf.caress functions. Let's take it from the top. So now we will look into the tf.caress.model function, and what this function does is it model groups layers into an object with training and inference features. When we get into the tf.caress.model documentation, when we go to compile, we see we could have this. This is just an example of what we can run inside our tf.caress. We have a compile. Inside the compile, we have the optimizer equals RMS propt, loss equals none, metrics equals none, loss weights equals none, weighted metrics equals none, run eagerly equals none, steps per steps per execution equals none, and then we have the KWRs. Now, all of these wouldn't be none when we actually run it. These are just none for example purposes. They will be specified when you run it to your specifications. Now, notice in our definition of compile, we see how by default our optimizer is RMS prop. Now, note that this optimizer or these different optimizers are essentially variants of the stochastic gradient descent algorithm. Also, so next we will look into these optimizers. So next we will look into optimizers. tf.caress.optimizers.sgd, and that's just the gradient descent with momentum optimizer. As we can see, we have added delta out of grad item, and we can see we have SGD. So this is the SGD we've already seen. So we can have this. This is just another example of how we can use the tf.caress.optimizer.sgd. We have a learning rate equals zero point 0.1, momentum equals zero point 0, Nestor OV equals false, name equals SGD, and then we have the KWRs. Again, these are just specifications. For example, when you actually run it, it'll be specified to the needs you have. So SGD will specify the learning rate. We have the momentum. We could increase this parameter so that we could speed up the training. And we could also specify if we have a nestor of type momentum. So when we see nestor of true, then we're having a nestor of type momentum. Let me go back up so I can show you an example of that. You see here that we have a nestor OV of false. That's because we don't have any momentum. So if it was true, we would have a momentum specified. And the learning rate is 0.001. Of all these optimizers, the most commonly used is the atom optimizer. And we see that many practitioners generally use this optimizer by default. And an example of that looks like this is the tf.caress.optimizer.atom. You have a learning rate of 0.001, beta 1 equals zero point 0.9, beta 2 equals 0.99, epsilon equals 1e-07, and the m's grad equals false. And the learning rate 0.001 beta. This is listing out what's inside of the optimizer.atom. Again, I'm not going to go too much more further into it. We did take a lot of notes this morning. We actually did draw a graph helping us break down certain models and certain aspects of the models. But again, we're not going to go over that into this morning. We'll keep that for another day. But if you stay with me, I'll keep you posted every step of the way. For now, this is the Python Papi. You guys stay Gucci.